Here we go. Chapter 7, Arrays. It's going to be fun. Wish me luck, as I say. We're going to be talking about arrays in Java, how they compare to a Python list, even how they compare to a Java array list, which is more comparable to the Python list. Let's jump right in. Python actually has both arrays and lists, but normally in an intro programming course, an intro boot camp, we just cover lists if we even make it that far into Python, because lists are just easier to work with. Even in Java, an array list, for the uninformed, the unexperienced, an array list is just easier to work with. So let's first cover Python. Lists, what's the value? They're flexible, they're easy to work with, they can contain heterogeneous elements, which are elements of the different types. You can have a list that contains integers, strings, doubles, tuples, if you know what those are. Your list can contain a variety of different types of elements. Arrays in Python, which do exist, are better in some ways. They're faster, they're more efficient with respect to speed, they're compact in their size, but they're less flexible. They must contain homogeneous elements. So all elements of that list must be of the exact same data type. So as I mentioned, usually in a Python course or a boot camp, we'll be covering strictly lists and not arrays in Python for the purpose of what? Lists are just easier, quite fun to work with, and you can really do a lot of cool things with lists. And we don't really need the value of arrays at that point. Java, we have lists as well as arrays. Now in Java, the list is called array list. The value of an array list, similar to the list in Python, they're flexible, they're easy to work with. They also can contain heterogeneous elements. The arrays in Java, like Python, are also compact in size. They're going to be very efficient with respect to speed. They're also going to be a little bit less flexible. You can make an array of different data types in Java to store different types of data when we come to generics, but for all intents and purposes, we normally think of the array list as being like the easier version of the arrays in Java. Same thing for Python. So we're going to cover both of them, but we're going to start with arrays, because if we can build a strong foundation with arrays, array lists are going to be like cake afterwards. It will be so easy. So here's an introduction program for this particular module, this chapter. Write a program that generates 100 random numbers between 1 and 50 inclusive, and then computes the average of those numbers. I'm going to jump over here to NetBeans, File, New Project, Next, and let's call this average. What is it? 100 random numbers, average numbers. Print average numbers is what I'm going to call this. Let's delete this package. Cool. And what do we need? We need to generate 100 random numbers, so we need to have random. So import java.util.star. We're going to make a random, let me zoom in for you. Random, type here, RNG equals new random. We're going to do a for loop, and we need to compute the average of all of these random numbers, which means we need a sum. Int sum equals 0, and the number should be between 1 and 50, inclusive of 50. So I'm going to say, let's add to sum rng.next int. And you can see here we can choose an origin and a bound. So starting from 1 all the way up to 50 is how this would work in Python. Now in Java, if you check next int, let me erase this. This is just a reminder. When we check next int right here and I just click it, it says return a pseudo randomly chosen int value between the origin, inclusive of the origin, and the bound exclusive, meaning if we wanted to go from 1 to 50, we need to put 1 comma 51 here. So generate those random numbers. add it to our sum, which we've done. I did not even bother saving the random number. I just added it directly into sum. And then finally, we want to print out. I want to print the average is percent point to F new line average. I did not save average, so let's make an average. Double AVG. And then here, compute the average. Oh, it's not Python. Compute the average. AVG equals sum divided by, and we said we need to do 100 random numbers. Sum divided by 100.0. So when I run this code, we'll get our average. The average is 26.35, which makes sense because we're generating numbers between 1 and 50 inclusive of those numbers. So the average should be around 25. And in fact, the more times you run this, the average should be even closer to 25. Here we ran it 100,000 times. So if I divide it by 100,000, yeah, 25.49, 25.52. The average should be honing in on 25 the more times you run it. If we only run it 100 times, you may get 27 as the average, as you see here, 24, and that's okay. So this works. Cool, that's easy. That has nothing to do with arrays. Here's our problem-solving phase, which I skipped and went right into the solution. Don't do that. And here is an implementation, which looks pretty similar to what I did. The only difference is here I had made random value, and I saved the generated number into random value, and then I said random value or sum plus equals random value. And I spelled this wrong, or what? What does it not like? Okay. I need to, of course, I'm thinking I don't need to initialize it, but I'm not wanting to put plus equals. So I'm generating a number, save it to random value, add random value to sum. That matches up with the code here. Cool, that should be easy. So now what I'd like to do, after computing the average, print all numbers that are greater than or equal to the average. So we've computed the average. If I run it, we see here, this is the average, 27. But now we want to print all numbers that are greater than or equal to the average. So I'd hit pause the video and think of how can you do that? How can we print all numbers before the average? So pause, think about a couple minutes, come back, and let's discuss. The challenge here, and the part that should have been at least a little bit confusing, is wondering how can I access those numbers? Like after I compute the average, now I need to print the numbers above the average. But you're going to be thinking, but where are those numbers? I never saved those numbers, right? All these numbers we generated, we never saved them anywhere. So we have no way of even accessing them or printing them. We just temporarily saved it to random value, added that to our sum, rinse and repeat. We did it again 100 times. So we never saved all 100 of those values into a list, which you could do in Python or here into an array. So the purpose of this ask was to have us think about and recognize, oh wait, I don't have any of those values. Well, what could I do? Well, here's a cheesy solution. We'd say, well, let's make 100 integer variables. Let's not do a loop. And let's just save every single generated number into its own integer variable, right? What a disaster if you simply took this line of code and you said int num1 equals that, int num2 equals this, int num3 equals this. You could do that 100 times and then add all those values together, num1 plus num2 plus num3 plus num99 plus num100. You could add all those values together, divide it by 100, and you will in fact get the average. What a disaster. We'd have 100 lines of code to calculate the average. But then we will have the values, we will have access to each of those original numbers. But what if we say it's 10,000 numbers? Are we going to make 10,000 integer variables? No, of course not. So it's a problem, but it's easy to solve with arrays or with lists or with array lists in Java. But right now the focus is on arrays. So what do? We make an array of size 100. We save all of these randomly generated values into that array. We then compute the average. And then after computing the average, we loop back over the array to identify all of the values that are equal to or greater than the average. And here's the code. So I've highlighted in blue, and it's bolded, the points that are now new. So notice here, this is how we've created an array. And then notice, after I generate this random value and I add it to sum, I also take this random value and I save it to position I of the array. So try to draw a parallel to what you would have done in Python, how you could have solved this in Python. So here we're saving it to position I of the array, and then we calculate the average. We print out the average, and finally, we merely loop over all 100 values and we check if a given value is greater or equal to the average, we print it. Now, hopefully, if you're with me, you recognize I didn't cover this in detail. And in fact, over here on the left, it says this is just a preview, like a trailer to a movie. We're going to go into the nuts and bolts of this. But I have a feeling that just with that very high level explanation, I think a lot of viewers or learners, we're going to understand what's really going on without too much more explanation. Because we don't need to know all the details, we're going to cover that. The problem is just to get an idea of what's going on. Overall, we make an array of size 100, we read the values, we save them into that array, and then we loop back over that array to see which values are greater or equal to our average. So now let's cover arrays. Arrays are used to do what? To store a lot of data, as we just saw. This collection of data we're going to store can be of any data type. But for now, let's just say that it must be the same data type. So you must have an array of just integers, or an array of doubles, or an array of strings, or an array of Boolean. When we get to OOP, we can have an array of student object references. But for now, an array of these data types that we know. You could declare 100 int numbers, as you've seen here, or you could declare a singular int array variable. Let's call that array variable numbers. And then we can save all of those numbers into that singular array, and we can access each one of them at their given index. So now how do we actually declare an array in Java? This is the syntax. You have to give a variable name, and then you have to specify the data type. Is it an array of integers? Is it an array of doubles? Or so on. And we have to use these square brackets to indicate that this particular variable, it is in fact an array. So here's an example. This is an array of doubles, and what is it called? It's called my array. We have declared this variable, and Java says, what is the data type of this variable? The data type is an array of doubles. These brackets, they should appear immediately after the data type with no space, and then after the brackets, you put a space and you give the name of your variable. Notable to say that you could put the brackets after the variable. This is more of a C or C++ syntax. It's allowed in Java, but the first way up here that I've shown you is what is preferable, and I would argue even more correct. It just makes sense. When we look at the variable, we say, oh, what is this variable? It's called my array. Cool. What's the data type? And then we look to the left and we see the data type is an array of doubles. So this is how you declare an array. But now there's a difference between declaring and creating. When you declare a variable of a primitive data type, space is reserved in memory for that data. If you say int x, just by declaring int x in memory, Java has made space for you to save an integer into x. This does not happen when you declare an array. An array declaration creates storage only for the reference to that array, but an array has not yet been created. And in fact, if an array has not yet been created, what is stored inside the array variable is simply the value null, meaning that this array variable does not yet point anywhere. It does not store inside it the address of where that array can be found in memory yet, because we have not created the array. So how do we create an array in Java? You've declared an array, you're ready to go, you want to save stuff in it. How do you create this array? You have to use the new operator. And here's the syntax. You're going to use the variable name that you just created, my array, equals new. And once again, you indicate the data type of the array. And here you specify the size. How many elements would you like to be in that array? So here's what we have. We have my array equals new double 10. And then we save all of that result into my array. So I'm going to come over here to the tablet because there's something very important to go over. Let's pretend this was an integer. If I were to have said int x equals new int of size 6. Now I'd like to ask, how many bytes make up one integer? One more time. How many bytes make up one singular int value? The answer is 4 bytes. So I'll put up here an int equals 4 bytes. Okay? An integer is 4 bytes. So what is this right here saying? This is saying, yo, Java, make me an array of 6 integers. Now, every integer is 4 bytes. So what this is really saying, yo, Java, go get me a big old chunk of space. How big should that space be? It should be 24 bytes. Right? Because one integer is 4 bytes. 4 times 6 is 24 bytes. Give me 24 bytes. What happens here with this 6? What that says is partition this space into 6 individual cells, which, as we know from Python, same as Java, will start at 0, and we can label the cells from index 0 to, I don't know why I put 6 there, index 0 to index 5. All of what I've shown you thus far is the right side of the assignment. Remember, in assignment, we have this assignment operator. We need to start where? On the right side. So we start on the right side of that assignment. We say new, that's a command. Yo, Java, go make me 24 bytes partitioned into 6 cells. And each cell is 4 bytes. And now that we've done that assignment, what actually happens? What do we save into X? What gets saved into X? The answer is, so X is going to be over here. Here's the memory for X. This array right here is not stored in X. What is actually stored in X? I always reference it with an address. I put with the asterisk. I put an asterisk there. And what does that asterisk refer to, or what is stored in X? The answer is an address for the beginning of the array in memory. One more time. What is stored in X? The array is not stored in X. What is stored in X? What is stored in X is an address. An address. What address? The address of the beginning of this array in memory. Why do I say the beginning? Well, this array is 24 bytes. So what is the beginning address of that array? And that is what is stored in memory. So that's a nice detailed drawing and explanation of what's actually going on when we create a new array. In this example here, new double, it would be the same exact concept, except how many bytes is a double? Remember, an integer is 4 bytes. A double is double that, which would be 8 bytes. So this is going to say, yo, Java, make me 80 bytes. Give me 80 contiguous bytes back to back to back in memory, and save the beginning of those bytes of that memory into the variable myArray. So you can declare in one step and then initialize or create that array in the second step, or as I just showed you in the drawing, we can declare and create the array in one go. Here we have an array of doubles. How big? Size 10. Here we have an array of 500 integers, which is 2,000 bytes, and we're going to save into myArray, this variable here, the address in memory of the beginning of those 2,000 bytes. So once we've created this array, as we've seen in Python, we can now save values inside that array. How do we save those values? By saving them at their specific indices. I can save 5.6 to index 0. I can save 13.2 to index 3. I can save all kinds of values to their respective indices. And so once again, if I make a new double of size 10, that's 80 bytes. I save the address of that 80 bytes into this variable mylist. And again, I can save values into the specific indices, which you see being done here. And here's a depiction of that array in memory. That here's the value being saved at index 4. We happen to save a 4.4 there. At index 9, we saved 11,123, right? At that spot in memory. And so the indices go from 0, it's 0 based, it goes from 0 up to the length of the array minus 1. So the length of this array is 10, the size is 10. So from 0 up to 9 would be the valid indices for this particular array. And then once again here we see that mylist, what's actually saved inside this variable mylist? It's an address. Or in Java terminology, we say a reference. A reference is what is actually saved inside mylist. Something else that is now cool and important to understand, we've talked about the stack memory in Java. What is that stack memory? That stack memory is a small area of memory that houses what? What is contained in the stack memory, or what is stored on the stack memory? The answer is all of the methods and their respective local variables. That is what is stored on the stack memory. And it's a very small memory. Now we have another area of memory called the heap memory in programming terminology. This heap memory is much larger than the stack memory. And what gets stored on this heap memory is our objects, our dynamically created data structures, such as an array. So it's important to know that the actual array, right here, this array, it's not stored on a stack. It's actually stored on the heap memory. And that is a nuance, but that nuance is very important. We're going to show you why it's important in just a bit. But this entire array and all of the values that are saved in that array, that is actually saved within which area of memory? The heap. Now, this variable, mylist, which stores the address of the beginning of that array, which is on the heap, this variable mylist, it's saved on the stack as a local variable within your running method. But the address that it points to for the array, that address is on the heap. So we have these two areas of memory. This distinction is very important, and we'll understand it better as we practice more and more with arrays and sending arrays to methods. We're actually going to be sending just an address. So creating an array. Here's another example. This is breaking down what I've already covered. Yo, Java, go make me an array of size 10. What's that really doing? Give me 40 bytes, because every integer is 4 bytes. Make a 40-byte contiguous group of memory, and then save the address of those 40 bytes into the variable x. And this is a depiction, again, of what's happening. We've created all of these 40 bytes. What actually gets saved into x is an address, or in Java terminology, a reference. Let's say that address and reference are synonymous. So I'm going to repeat this one more time because it's so important. But then as you see here, I'm going to say we'll just call it an array. Array variables only hold a reference to an actual array. This variable x does not store the array. Where's that array stored? On the heap. Where is this variable x? It's on the stack. It's a local variable belonging to a method. What is stored inside x is an address. An address to what? An address to the beginning of the array in memory. Which memory? On the heap. Array variables only hold that address or that reference to the array that is stored on the heap. So strictly speaking, an array variable is different from an array. This is the array. This is the array variable. The array variable is stored on the stack, and it contains an address. An address to what? To the array, which is much larger and is stored on the heap. That distinction is very important to understand, but I say at the same time, we can normally ignore that distinction, but we understand it. So meaning to make things simple, we're going to say that my array, when I come and I look at this example, I'm going to say that my array is just an array. Or x, I'm going to say x is an array. We can just say that to make the conversation easy, as long as we know in our heart of hearts that x is not really an array. In our heart of hearts, we know that x is a reference or an address that points to an array which is stored on the heap. That distinction is huge, but we don't want to have to say every time, what is x? X is an address that points to the array is stored on the heap. That's a mouthful, right? It's easier to say, what is x? X is an array. We can say that with the condition that we understand that x is not really an array. X is an array variable that points to the array or refers to the array which is stored on the heap. So for the purposes of making conversation easy, that's what I'll state, as long as we know in our heart of hearts what really is stored inside x. So array size, what's cool, like a string, if you make a new string, you can call .length. It's a method, it has parentheses, and you can get the length of that string. Well, Java gives you a built-in operator to get the length of an array. And that is simply myArray.length. Notice there are no parentheses. This is not a method. This is just a built-in functionality of arrays. If you say myArray.length, if the array was declared to be of size 10, well, that will return to you a 10. Important to note is that once you create an array, you cannot change its size. If you make an array of size 10, you can't make it smaller afterwards to size 5, or you can't make it larger to size 20. Once you create an array, and that's a negative, the size is static, it's fixed. It cannot be changed. And here's what I just mentioned, that the .length is not a method. Instead, .length is simply a special property of arrays in Java. So when you create an array, those arrays are given default values. So a numeric array, such as an array of integers or longs or an array of float or double, those individual cells are assigned default values of 0. For character types, the individual cells are assigned a default value of this Unicode value 0000. And then finally for Boolean types, every cell is given a default value of false. This is just quick reminders. We've studied this in Python, that array indices are 0-based. It's going to go from 0 up to the length minus 1. So again, if an array has size 10, it'll go from 0 to 9. That's straightforward. We know that. And then here is an example that we can use arrays just like regular variables. The following code, we add the values in myArray0 and myArray1, and we save it to myArray2. Pretty straightforward. This is an assignment. Come to the right side. We take what is in myArray0, we add it to myArray1, we save it into the variable myArray2. Pretty straightforward. And here's one more example. This loop, what does it do? It assigns 0 to the index 0 of my array. Then it assigns the value 1 to index 1. Then it assigns the value 2 to index 2 of the array, all the way up to it assigns the value 9 to index 9. Because if the length was 10, we're going to loop from 0 to I less than 10. And what are we going to do? We're going to save 0 to index 0 of the array. 1, I is 1 to index 1 of the array, all the way to 8. We save the value 8 to index I of the array, and then we save the value 9 to index 9 of the array. Java also gives us what is called this shorthand array initializer, where you can declare your array and you can initialize it in one go without actually using the new keyword and saying new double of size 4. So here we have double my array equals, and we have this pair of curly brackets with 4 doubles inside of it. Java gives you this shorthand method of doing that. That would in fact be equivalent to these entire 5 lines of code. I could have made an array of size 4 doubles and then individually saved 1.9 to index 0, 2.9 to index 1, and so on. Or I could have made it directly like this. Now, to be honest, it's something that's not as commonly used because usually you're not going to be declaring arrays with specific values inside of them. Rather, we're going to be reading values, maybe it be from the user, from a file or something else, generating values, grabbing values, and we're not going to normally just be using this shortcut initializer. But it's something to know that it's available to you, and there are times where it can be helpful, and we'll show you a program shortly where that will be very helpful. A caution is that if you do this array initializer, if you want to ever use it, the syntax is that the declaration and the assignment must all be in one line. So as I showed you on this example, here we declared it, we gave the variable name, and we initialized it all in one line. That's the only way you're allowed to do that in Java. Meaning, if you try to declare the array on one line, and then on the very next line, if you try to initialize it, this would give you an error that is not allowed. Processing arrays. Array elements are processed using loops. And since we know the size of the array, it makes sense to process an array with a for loop. All of the elements in the array are the exact same type, so we can use a for loop to repeatedly access those elements. And again, the size is known, so it just makes sense to use a for loop. So consider the following example program. We're going to create an array of size 5, and we then want to loop over that array, to iterate over that array and modify the values of this array of size 5. So we have this array here of size 5 integers. We've saved the address of that array into this variable values. And so here's the array right here. Everything has a default value of 0 as we've discussed. And what follows is we have a for loop. We're going to loop from 1 to less than 5, which means we're going to loop 4 times, right? From 1 to less than 5. And at every iteration, we're going to increment I by 1. So we're looping exactly 4 times. I starts at 1. 1 is less than 5. What happens here? We'll just follow the assignment. Here's the assignment. Look to the right. And what do we see? We see I, which is 1, plus the values at index I minus 1, at index 1 minus 1, since I is 1. So the values at index 0, which is currently 0, add that to the value of I, which is 1, and then save that result into values at index I, which is 1. The consequence of which is, the result of which is, we now have 1 at index 1. Okay, I plus plus, I is 2, 2 is less than 5, rinse and repeat. What do we do here? Take the values at index I minus 1, so at 2 minus 1. So take the value at index 1, add it to the value of I, which is currently 2, so now we get 2 plus 1 is 3, and then save that into index 2. So we save a 3 into index 2. I plus plus, I is 3, 3 is less than 5. What do? We take the value at index 3 minus 1, the value at index 2, which is 3. We add that value to the value of I, which is 3. 3 plus 3 is 6. We save 6 into index 3. We get another I plus plus. I is now 4. 4 is less than 5. And we do this again. We take the value at index 4 minus 1. That's the value at index 3, which is 6. We add that 6 to the value of I, which is 4. We get 4 plus 6 is 10. And we save a 10 into index I, which is index 4. This is the result. Now we get an I++. I is 5. 5 is not less than 5. We finish this for loop, and then we happen to have one final statement outside the for loop. What does it do? It says take the value at index 1, right here, plus the value at index 4, which is the 10, add them together, and assign that result into index 0, and this is what we get. So this is just a quick animation to show you how we can process through an array and loop over that array. A reminder and something we probably are comfortable with lists, but nevertheless important to practice that. What follows here in the next maybe 10 or 15 minutes, I'm trying to be cognizant of time, is we want to see several examples of array processing. We want to print an array, we want to initialize an array with input values, also initialize an array with random values, sum all the values in the array, find the largest element, find the smallest index of the largest element, and even more. It's going to be fun. Let's go right through this. If you're given an array, how do you print that array? We simply use a loop to iterate over every single index of the array. And I don't know why my print statement is not showing. I'm going to come here to my chapter 7 notes. Let us just make an array. Int array x. Let me zoom in for you. Int array x. Let's do the shorthand notation. And let's save in here the values 1, 3, 5, 7, and 9. So I could absolutely print all values in x for x.length. Make sure we do not put parentheses. This is not a method. As I said, it's a built-in functionality of arrays. So it's just x.length. And what do we want to do? We want to print out x at index I. And when I run this, we should get 1, 3, 5, 7, 9. Pretty straightforward. If we wanted to make the print statement nicer, we could do this. We could do formatted printing. And let's do this. We want to print x at index %d colon %d. And what are we doing here? Here the %d is the index itself, so that's the ith index. And then here I want to print the value at that index. So this is going to be x of I, x index I. And we run this code. X of I, x at 0 is 1, x at 1 is 3, x at index 2 is 5, all the way to x at index 4 is 9. So pretty straightforward. Again, this is all something we've done with lists already previously. What if we would like to initialize an array with input values? So instead of doing this shorthand notation, what if we want to maybe ask the user to enter 10 different doubles? We make an array of size 10. We want to tell them to enter 10 values, and then we do a for loop to loop 10 times. And at every single time we say my array at index I equals input.nextDouble. So we'd be calling the nextDouble method of the scanner object to scan a double and save it to index 0, then to index 1, then to index 2, all the way to index 8, and then index 9 on an array of size 10. So here's how we could initialize an array with input values. I won't type this one up because I don't want to read from the values every time, from the user every time I try to run that array. What if we want to initialize an array with random values? So let's make another array up here. Int bracket, let's call it random array. Random values equals new int. How big do we want this? Let's make it size 10. So if I want to initialize that array of random values, I need to do a loop. I'm going to loop random values dot length, not a method. Don't put parentheses. And what am I going to do here? I'm going to save at random values at index I. I'm going to save a random value. Did I say what size the random value should be? No, here it's times 100. It's using math.random. Let's actually use the random class. Let's make an object of type random. Random RNG equals new random. This is cleaner. And then so here, what am I going to do? rng.rand or rng.next int from 0, 101. That would go from 0 to 100. This would go from 0 to 99. So I've now generated those random values. If I want to print it, let me comment this. Generate array of random values. If I want to print that array, I'm just going to copy this line of code, the above for loop with its comment, and let's print all values in random values array. So it's not going to be x.length, it's going to be random values.length, and as we're not going to be printing x here, it'll be random values. Let's run that code. And we got an exception. Where's my end of, I did something silly. What is it? I need to go find the number 25 right here. Oh, because I'm calling x, of course. That's silly. So I'm printing the value at the random values array, not at the x array. So here's what we have. I generated random values between 0 and 100, not inclusive, so between 0 and 99. And then we saved those values into the respective indices, and here is the result of that array. Hopefully that's okay. You can always pause, back up, type up the code, look for errors, and make sure you're good. So this is initializing with random values. What if we want to sum all values of that array? We want to sum all values inside, let's just say this random array right here. So I need a sum variable, and sum equals 0. I need to do a for loop. I'm going to loop over random values dot length. Again, don't put a parenthesis, right? And then what am I going to do? I'm going to say sum plus equals random values at index I. That's it. And then afterwards I can say, I'm going to do formatted pring. The sum of all values in the random values array is %d, period, new line, sum. Pretty straightforward. Run this, and we get the sum of all values is 510, is the sum of values in that array. The takeaway of the purpose of showing you these various for loops or solving these various problems of processing arrays, printing the array, initializing the array with random or input values, summing all elements. The takeaway is, look, it's the exact same for loop. We're looping over the length of the array and we're doing something. Here we're assigning a value. Here we're printing a value. Here we're adding the values to sum. It's all the exact same idea. Find the largest element. Find the largest element in an array. Or let's say in the random values array specifically. So the largest element means we need a max variable, right? So int max equals, and we'll show you what you want to initialize that to. Now we can safely initialize it to -1, but we'll initialize it in just a moment. So here, let's do a for loop. We're going to loop over random values dot length, no parenthesis. I'm doing that on purpose so we can get in the habit, no parenthesis. This is the length operator for arrays. It's not a method. And what do I want to do here? I want to check if the value at index I of random values is greater than our max. We have let's make this comment over 2 lines. If it is greater than our max, then we found a new max. So if random values at index I, if it's greater than our max, what does that mean? We found a new max. I can say max equals random values at index I. Pretty straightforward. Now the only problem is we need to initialize max here. What does it say? Variable max may never have been initialized. So you say, okay, well, what do I initialize it to? And you can make it 0. You don't want to make it a positive number because that'll be bigger than any of the values in the array. So I'm going to show you the wrong way to do it and then the right way. The wrong way, and it's not completely wrong, but the wrong way is to first ask yourself, well, what are the values that will be in this array? If you know that the array is made up of these random numbers from 0 to 99 inclusive, you know that all of those numbers, 0 to 99, are bigger than minus 1. So you could safely make the max minus 1, no problem. But what if we didn't tell you what was inside this array? It could be negative numbers, it could be positive numbers, it could be 0. We don't tell you. So what is a safe number to initialize max to? What's a safe number? The answer is you want to initialize this to choose the smallest possible int value. That's what you'd like to initialize it to, because if you choose the smallest one, so imagine you make it 2 billion. That's a pretty small int value. Most things will be bigger than that, right? But there's smaller integers than that. That's not the smallest. So now you're like, well, man, what's the smallest integer? You could go look it up, or you could just type integer dot min value. That will save into max the smallest possible integer value, which means what? That any value here is guaranteed to be greater. So now let's print. The largest value in the random values array is %d max. Run it. Let's see what we get. The largest value is 94. Is that accurate? I was about to say I don't see a 94. That would have been a disaster. There's the 94. The largest value is 94. If I run it again, it'll be a set of different numbers. What's the biggest value here? 83. Oh, we got a 98. The largest value is 98. Cool. What's next? Find the smallest index of the largest value. Ooh, that one's different. Find the smallest index of the largest value. And we've seen one of these previously when we were just doing loops. So if I want to take all of this code, let's just do it again. But I can't redeclare max. So I'll just say int max. And now I want to call this smallest index. So int smallest index max value. It's a long variable name, but it's clear. We need to initialize this. So let's initialize it to an invalid index, which is -1. And we also need to keep a current index. No, I don't think we need to. So here, let me think about this. We need to find the smallest index of the largest element. So first of all, we just simply want to loop over all values, try to find the largest element, and every time we find a new larger element, what do we want to do? We want to save index I into smallest index max value. That's what we want to do, to show, well, here is the index where we found this maximum value, right? So imagine, so here we found a 33. 33 is currently the maximum, so we would have saved 0 into here. Then we find the 83. 83 is now the maximum. We save 1 into here. But check this out. We find another 83. 83 is no, 83 here, this 83 at index 2, is not any larger than the previous 83. So it's not a new maximum. This will not be true. We will not execute this, and we will not execute this, which means even though we have multiple 83s, the current value saved in smallest index of the max value is in fact 1. So that one change actually works perfectly for us on this particular problem. So what was next? Random shuffling. Let me skip ahead here. We did find the smallest index, done, and then we have random shuffling. What if we're given an array, such as we have this array here, random values, and we would like to shuffle that array. Shuffle the random values array. How do we shuffle it? What do we mean? We mean swap two values, right? Swap two values in that array. So how can we do that? Well, to shuffle it, you want to do that many times. So maybe we'll shuffle it the number of times equal to the length of that array. So I can say random values dot length. Again, don't put parentheses. And we want to shuffle, meaning we want to swap the values at two indices. We want to do this at every iteration. Swap the values at two indices for each iteration of this loop, which means we need to generate two random indices. Ooh, gotta think about that. So now, generate two random indices. We will swap the values of these, or the values saved at these two indices. So how do we do this? Let's first up here, let's call this, let's make two integers, idx1, idx2. Those are two indices. And how do we generate a random index? Well, we can use our random number generator. idx equals rng dot next int. And we want to go from index 0 up to, what is the last possible index? If the length is 10, what's the last possible index? 9, right? So we want to go from 0 up to 9. But remember, this last number here within the next int, it's not inclusive. So if we want to go from 0 to 9, we really need to put 0 to 10. Well, where do we get this 10? It's just random values.length. So perfect. Let me make sure I put an H here that I forgot to copy. So now we have index 1 is RNG. We're calling our random number generator dot next int from 0 to random values.length. And we do the same thing for index 2. So now we have two indices. And we are ready to swap those two values. You likely remember to swap two values, you need a third variable, a temp, and it's the famous three lines. We can do this quickly. We've done it several times. Temp equals the value at index 1. So this is going to be random values at index 1. Then we're going to take what was in index 2, and we're going to save it into index 1. So now we've overwritten what is inside index 1, right? This right here, it takes what's in index 2, we save it into the random values at index 1, and I'm calling it index 1. It's not index number 1 or number 2. It's these randomly generated indexes that I have from above. So take whatever's at that second randomly generated index and save that value at to the position in the array of the first randomly generated index, which means we're overriding what was already there, but no harm because we already saved it into temp. And then finally, take what is in temp and save it into the position of the second randomly generated index. It's a mouthful. So that's now done, and that's our shuffling. When I run this, we shuffled it. Let's print it afterwards. Print the array after shuffling. And let's go copy that print statement above. Here is, where's the printing? And here's the printing. We want to print all of the values after shuffling and then take a look at it to make sure that it looks pretty good. So we had from 94, 39, 82, and now we get 82, 38, 39. It's been shuffled, just randomly shuffled. What did we do? Is we loop over the length of the, not loop over the length, loop the number of times equal to the length of the array. And we could have done 2 times that. What if we said, you know what, let's loop that amount times 2. We want to shuffle not just if the array is 10, we don't want to shuffle just 10 times. We want to shuffle 100 times. We could have done that. Let's loop 100 times. It's like shuffling cards. How many times do you want to shuffle it? So each time we generate 2 random indices and we swap the values at those 2 indices. And here is a new result. Cool. What's next? We have shifting of elements. And this is the last example. Shifting of elements. What if you wanted to take all your elements in the array and you want to shift each one backwards 1 spot? right? How do we do that? And then we want the element that's at index 0, we want it to come all the way back to the end, right? So let's come over here to our trusty tablet, and let's erase some of what we've had here. And so I want to think about this. You know what? Actually, I like this. I want to keep the array. Let's keep that array drawn out, and we'll use this one. So imagine that we have values that are already saved in here. We have, let's say this was 4, 8, 3, 9, 12, and 7. And we would like to shift all of these values to the left, meaning we want the 8 to get stored here, the 3 to get stored here, the 9 here, the 12 gets stored here, the 5 should get stored at index 4, and we need the 4 at index 0 to get stored over at index 5. Think about how we make that happen. What would be the correct way of making that happen? There's a correct way to do it, and then there is an incorrect way to do it. So the correct way to do it is exactly what I just drew out. Take the 8, right? And we're going to take this value here, and we're going to save it to right here. So now we have 2 8s. Then we take the 3, and we save the 3, and we overwrite the 8 with the 3. That's the correct way of doing this. An incorrect way of doing it, a disaster, would be take this 4 and save it to right here. So now this becomes a 4. And now take whatever's here and save it right here. So this becomes a 4 as well. Take whatever's there and now save it here. The result of which everything becomes 4, which is, of course, a disaster, not what we want. So doing it in the other order is precisely what we'd be looking for. So if you notice here, we're going to loop from index 1, not index 0. We're looping from index 1 all the way through the length of the array. And we're going to take the value at index 1, we're going to save it to index 0. Then we do I++. We take the value at index 2, save it to index 1, right? We keep doing this. I'm going to come back to the tablet. We do this for each one. Let me come back here a little bit. So we take the value at index 1, save it to 0, take the value at index 2, save it to index 1, the value at index 3 to 2, from 4 to 3, finally the value at index 5 to index 4. Then we said the last thing we want to do is we want to take what was here at index 0 and we want to bring it over here and save it into index 5. Which means what? Which means we would have had to have saved that 4 first. Maybe save it somewhere over into temporary memory so we can bring it back around and save it to index 5 afterwards. And that is precisely what we did up here. We said double temp equals my list index 0. We saved 0 off temporarily. We did this shifting of elements, and then we moved temp to index length -1. Hopefully that's okay. We're going to talk a little bit more about, let's see, this is cautions. Let's cover this very quick caution and simplifying of coding. Simplifying coding that we showed earlier, that if you've made this shortcut notation, which is not common, but here's an example where it's valuable for you. So hypothetically, if we wanted to, given the number, we ask the user enter a number representing the month. And if they enter 1, we want to print January. Enter 2, print February. Enter 12, print December. Look how long this if-else statement is. It's 12 long, right? If it's 1, else if it's 2, else if it's 3, all the way to else, it would be 12. Look at this long if-else statement. But look at what we could have done had we did it this way. If we simply save a listing of the months into an array, we make an array of strings, and we set it equal to, and we go ahead and we type in all of the strings of those months. And notice I even use an empty string here. So the size of this month's array is going to be size 13, where January is stored at index 1, December at index 12, and so now I think you can see why I did this, because I wanted to pad that over a little bit. If I didn't put this, it's no problem, but January would be stored at index 0, December at index 11, which is not what I want. So by putting this empty string, now January's at index 1, December at index 12, and check it out. Enter a month number, they enter 1 to 12. I scan in the month number, and I can just print the month is months at that month number. So here is a use case where this shortcut method of making an array initializer is actually valuable for us. Common errors, just very briefly, array index out of bound. It is going to be the absolute most common error. We will be getting it often. It'll make us angry. It'll make us sad. It will absolutely make us want to give up. We will see it all of the time. And we don't need to see it all the time if we're careful. But the problem is we're usually a little bit heedless. And if you have an array of size 10, too often students will loop from index 0 all the way to index 10, which does not exist, right? An array of size 10 only has index 0 to 9. So you all want to be very careful for looping from index 0 to less than the length, not less than equal, which is what you see right here. This will give you that index out of bounds exception. The best of us even will see it and will encounter it. It's a very common exception to have. I'll leave you with this. Feel free to pause the video. A nice little checkpoint to trace through an array. Being able to trace code, to look at code, and to be able to, without running it on your computer, but to just look at it, to grab a pen and paper, and to trace through it, a very important skill that you want to be able to develop and practice and hone. So I would pause the video, I'd look at this particular code, and I'd try to trace through it and see what we come up with. It's been fun. As always, reach out, leave a comment, message if you need anything. Take care, everyone.